All right. Hello, everybody. Welcome to the tailor-made session. So we have 6 papers in this session, and we'll have the talks in sequence, and then following the 6th paper, there'll be an interactive Q&A session right outside of the room where you can speak one-on-one with the authors. So we'll get started right away. I'm Emily Whiting. I'm a faculty member at Boston University in computer science, doing computational fabrication, and I'm your session chair. And starting with our first paper today, we'll be hearing about fast physics-based modeling of knots and ties using templates. And our authors are Zhewen Guo, Zhendong Wang, Zigao Liu, Sheng Li, Guoping Wang, Yin Yang, Huamin Wang from Peking University, Style 3D Research, and University of Utah. And our presenter will be Zhendong Wang.
Thanks for the introduction. Good afternoon, everyone. I'm Zhendong Wang, a senior researcher at Style 3D Research. Today, I'm excited to share our work on fast physics-based modeling of knots and ties using templates. Okay, tying a necktie is a daily routine for many businessmen. On the other hand, adding a knot to women's clothing often makes it more stylish and fashionable. Okay, now please look at me. I'm holding a wrap in my hand. With my both hand, I can tie a bow knot easily, right? Okay, let's make things a little more interesting. What if I try to tie a bow knot using just one hand? Okay, well, I give up. I can't do it, so you can try. Tying a bow knot with just one hand is already pretty tough, but what about doing it with a mouse cursor in a digital 3D world? That's totally a late mail. Someone even posted about this on YouTube, saying this is so difficult to achieve. And I was close to desperation. Okay. And someone also added a comment that said, takes lots of practice. Good luck. Practice makes perfect. Okay, to tackle this problem, our solution is utilizing parametric templates. We begin with a straight scarf. The first step is designing a scarf template, and then we map the flat scarf mesh onto that template. With penetration-free simulation, our method can efficiently model a scarf wrapped around the neck in just a few minutes. By designing several parametric templates, our method can efficiently model a variety of knots and ties across different garments. Our parametric templates are defined using Bezier curves with adjustable radii. These curves are shaped into knots without self-intersections. We then tessellate the template into triangle meshes to enable self-collision detection and accurate knot mapping. Each template has parameters like size, orientation, and tightness, which give us flexible control over the shape. Finally, we can map a closed mesh onto the surface of the template to form specific knots and ties. Knot mapping bridges digital design with real-world physics. Our system offers 2 powerful ways to make that happen. First, there's a rectangular mapping. So you can flatten a cylinder surface onto a plane. Then any piece of cloth you place on that plane can be mapped back onto the cylinder's surface in 3D space. With its padding parameters, it provides surgical precision, which is perfect for structured, well-defined knots. And secondly, we have circular mapping. Instead of using a rectangular plane, you can also flatten a cylinder surface into a circle. This method is ideal for knots which is tied at one end. Now take a look at these blue ties. With zero padding, we end up with a tight look. However, if you add a bit of padding, then the look changes a lot. The knot becomes softer and more relaxed, which is perfect for a casual look. This example shows that how changing the orientation parameter affects the shape of the scarf load. As we adjust the value from 0 to half pi and 2 pi, the same plane pattern follows in different directions. And as you can see in the bottom row, these digital designs translate beautifully to real-world variability on the mannequin. And after mapping, our penetration-free simulation ensures that the knot structure stays intact during the relaxation process. Our simulation system has two key components. The first is a fast primary simulator using Gauss-Newton optimization, which provides real-time feedback and stable performance. Second, an IPC-based fallback simulation mechanism guarantees strict collision safety when we need it. Okay, let's see some results. At the core of our simulation are parametric templates that control Bezier curves to model knots without collisions. Designers can tweak parameters like radius and size, while the system handles all the complex geometry behind the scenes. And for performance evaluation, this table shows how long it takes our method to model different types of knots. Most knots can be modeled in under 10 minutes using our method. In comparison, traditional manual modeling usually takes over an hour for the same results. Let's see some dynamic results. Here are more results from our method. Once the knots are modeled, their spatial structures can stay stable even during dynamic animations. When knots are added to a handbag, they instantly elevate its look with a touch of elegance and flair. Okay, to conclude, our method offers a fast and reliable system for modeling knots and ties. That said, there are still some limitations of our method, like the need for manual template creation, and we hope to tackle this problem with automatic procedural method in the future. Is this end? No. By the way, we have integrated our method into the latest version of our product, which is called Style3D. With Style3D Studio, it's super easy to model stylish garments with beautiful knots. As you can see, all you need to do is placing the girdle in the right position and pick a suitable template, then select to mapping area. Our method performs the mapping process instantly. You can also swap the mapping areas and adjust the knot's position and the parameters. Okay. Finally, what you need to do is just click the simulation button and you've got a well-structured knot. So everything is ready to go. Okay, so if you are interested, feel free to scan the QR code on the right to learn more about Style3D. Okay, thank you so much for your listening.
Thank you very much for that nice presentation.